On this edition of the Happy WorkLife Podcast, I'm delighted to be joined by Professor Sir Adrian Hill. Adrian is the Lakshmi Mittal Professor of Vaccinology and the Director of the Jenner Institute at Oxford University, which he founded in 2005. He is one of the leading authorities on malaria vaccines, but in addition to that, in 2020, the Jenner Institute initiated a major effort towards rapid deployment of a COVID-19 vaccine in collaboration with AstraZeneca. Adrian has published over 600 research papers with 60,000 citations and co-founded several spin-off companies. He's also a fellow of the UK Academy of Medical Sciences, Royal College of Physicians, and the Royal Society. Adrian, welcome to the Happy WorkLife Podcast. I'd like to start by talking about your early years. You're obviously now eminent in your field, but when you were at school, did you think that you would go on to do the things that you'd done?
In a word, no. I guess you're referring to me working now on vaccines and having done that for 20, 30 years. No, that wasn't part of the plan. And I think if you'd asked me when I was 15 what I really wanted to do, the answer would have been to play rugby. And given my size, that probably wouldn't have been a terrific idea. I was a scrum half, but I really enjoyed games. And playing for the school was amazing. You'd have hundreds, thousands of people from the school, maybe not thousands. But we did play in what is now the Aviva Stadium for one of the cup finals. And that was extraordinary and memorable.
So you're obviously quite good at rugby and sport.
Yeah, I was okay, I guess, as a sort of nippy, small scrum half. But once everyone else grew up even more, that wasn't really an option.
And what about academically? What did you enjoy at school and perhaps enjoyed less at school?
Yeah, I think that's simpler. It's partly, of course, in life, not so much what you enjoy, it's also what you're good at that determines where you end up. My father was a scientist. He was a chemist, became a food scientist. My mother taught biology and chemistry at secondary school. So I guess looking back, it was reasonably likely I'd be okay at science, and I did enjoy that. When the time came to make up my mind about what I was really going to do at college, I applied for medicine and got a place, and of course that's largely science in the early years.
And where did you decide to study?
Yeah, well, I grew up in Ireland, in Dublin, a sort of 20 minutes walk from the centre of the city. So that was kind of lucky. Couldn't afford that these days. And I suppose being good at chemistry and biology and knowing that you'd probably make a living if you became a doctor, going into medical school was kind of the thing you did for many of us if you could get there. And certainly, I've no regrets about doing that. Biomedical science is fascinating. It's what I've ended up doing for decades. And I was lucky enough to have one of these entrance exam scholarships where you kind of competed, and then they even let me through on a kind of fast track into the first year of medicine rather than doing what was called a pre-med year. And that was at Trinity College Dublin, still the best university in Ireland.
And how would you describe your time there?
Busy, in a word. I did, you'd had, I don't know, 1,000 clubs you could have joined or something ridiculous like that, and tried to do probably too much, from playing rugby to singing in the choral society. I liked classical music, and met members of the opposite sex kind of for the first time. I was at a boys' school in the centre of Dublin. So yeah, lots of new experiences.
And when you were there and you were studying medicine, did it always feel that was the thing that you would go on to do? Or did other things pop into your head, other career routes come across your path at that time?
Not to any great extent. I wasn't terribly good at anything else. I'd love to have been a concert pianist, but no chance at all. Didn't practice enough either. So after grade 8, that was pretty well it. But I suppose what appealed to me in medicine was more the scientific underpinning of what was involved in medical care, and was, I suppose, always likely to do a PhD after my first few years, which is almost what happened, but that isn't actually what happened. What actually happened was I got on a boat in Dublin and went to England and met a tutor at Magdalen College here in Oxford, who, I think to his amazement as well as mine, ended up offering me a place in the college. And that was as a transfer student from Trinity College Dublin, with the idea that I'd be funded for a year, I had a bit of money, and go back. And I kind of stayed, and here I am, 40-something years later.
And when you came across to Oxford,
Mm.
what did you specialize in? What did you focus on?
Yeah, so Oxford, as you may know, is a 6-year medical curriculum. So the first 3 years end up with you doing a degree broadly in biomedical sciences, often called physiological sciences. And I did well in that exam. And then I got a scholarship from the medical school to stay on and do the clinical years. And therefore, I had to rather meekly go back to the guys in Trinity who said it would be fine to go to England for a year and explain that it would be longer than a year.
And when you were at university, did you still play your rugby?
Yeah, but increasingly implausibly, because people were bigger, and physical training was something I didn't really take terribly seriously. So basically, I was too small to be competitive. And yeah, I'd love to say that I did, but again, there wasn't really time. And by then, I'd figured out that what I really wanted to do was see a bit more of the world, and focused quite a bit on that.
And in the introduction, I talked about you being an expert on malaria and your role, of the Jenner Institute's role in COVID and working with AstraZeneca. So our listeners have heard all about the sort of the end state, but I'm really keen to hear about how you got there, how you achieved all these amazing things. So you're at Oxford 6 years. Just how did the journey take you to where you are today?
Well, viewed through the lens of what's happened in the last few years on vaccines, particularly for malaria and COVID, where we've made contributions, the answer is almost nothing. I don't remember in 6 years of medical school a lecture on vaccines. So that's something we've been trying to put right here in the last few years. And to be honest, I didn't start to do anything on vaccines till around about the 1990s, after I'd been doing research for quite a few years. And what really excited me when I was a new medical graduate was what was happening with DNA and genetics, and the extraordinary power to understand biological science that would come from being able to sequence every nucleotide in the human genome. And that was a great quest at the time. There was a Human Genome Project, seems millions of years ago now, but of course, genomes are sequenced every day very easily, and there's masses of information in there. So the short answer to your question is I became a human geneticist because I thought that was exciting and different. And the head of the medical department I was in Oxford was a very well-known, very distinguished geneticist called Sir David Weatherall. I still remember going, tiptoeing into his office meekly, answering his questions. And he said, "What do you really want to do?" And I said, "Well, I'd really like to do a PhD in genetics." And to my amazement, 10 minutes later, I left his office, and he'd said yes. So that was a transformative moment. Did my PhD, went back and did a bit more clinical training in London and elsewhere. And since then, once I became a senior research fellow, research was the focus, but for many years still it was human genetics. And it was only in the 1990s I started thinking about vaccines. And that was spurred really by having traveled. I traveled to Melanesia, the South Pacific, for genetics. I traveled to West Africa to look at malaria susceptibility. And it was blindingly obvious, certainly to me, that what West Africa really needed to stop kids dying of malaria was a vaccine. And understanding why some died and why the others didn't die might have been to do with genetics, but really that wasn't the priority. The priority was controlling the disease, and there's been huge progress in that area.
So how did you go about starting work in that area then? So there you are, you're whizzing around, you're looking at genetics, you're thinking about what you can do, and then you see this need for malaria. So where do you start?
Well, the answer to that's very easy in research. You can't do anything if you can't raise money. And I remember one of my distinguished elders at this university saying, Adrian, you know, the most important scientific ability is the ability to raise money. And I thought that was such a crass statement made by a very distinguished individual that I was horrified. Nowadays, I think it's so obvious it's barely worth saying. So yeah, I started writing grants, looking for funding agencies to support the research I wanted to do, and was very lucky that the Wellcome Trust in London were in the right place at the right time. And I've been supported by them really on and off for the last 30 years. So yes, and the great thing about writing grant applications rather than being told what to do is you have absolute freedom to write anything you like, as long as there's a fair chance you might be successful and somebody would give you the money to do that research.
And is that a constant strain, continuing to find the funding for projects? Has it become harder over the years, Adrian?
I don't know. It's hard to judge because there's more money in the system now. There are more funders for global health. You know, 20 years ago, we used to call this tropical medicine, and it was a bit of a niche activity. We now appreciate in some countries in the world, not all, that having people whose daily income is 100 or even 1,000 times less than people in richer countries is just not just unfair, but totally unsustainable and outrageous. And that health is a big driver of poverty in the lowest income countries in the world. So yes, there's been a lot of improvement, a lot more awareness over the last 20 or 30 years, but you still have governments that I won't name in this world who think that that is not a priority, and it's fine to have the average African earning 100 times or more less than the average American.
And then your work in malaria. Just talk to us about what you've developed, what you've discovered, and then all the amazing things that have come off the back of those discoveries.
Gosh, I'll try and be brief. I could get very boring about malaria. It's a fascinating disease. It's not caused by a virus. It's not caused by a bacterium. It's caused by a parasite. And it's the worst parasite we have on the planet in terms of the number of people that it kills every year. And one of the things I learned being a geneticist is you can figure out roughly how long malaria has been around in human populations. And the answer, bizarrely, is 35 million years. Now, we weren't around 10 million years ago, let alone 30 million years ago. We've evolved, but the malaria parasite was. So what I tell the students is it's had a bit of time to think about our defenses, about our immune system, and it's adapted in extraordinary ways that allow the parasites to go on living in huge numbers of people without killing them and transmitting to other people, and that's good for the parasite. And more people end up getting infected. In the last 50 years, there have been huge advances, of course, with drugs, with spraying of insecticides to kill the mosquito that is required to transmit the malaria parasite. And literally in the last year, 2 vaccines have appeared. One of them, the one we developed in this lab I'm sitting in. So there's been progress, but it's still a very wily enemy that adapts very rapidly in different ways. It's got a huge genome for a microbe, and it's got this bizarre life cycle where it goes through mosquitoes into your skin, into your liver, into the blood. Then you might notice there's something wrong. A week later, you might be dead. And then another mosquito comes along and infects other people. So you might think that's weird and wonderful, and it is, but it's also terrible. It does give you lots of opportunities to intervene, whether it's with insecticides or with drugs or vaccines or monoclonal antibodies and new things that have come along in the last few years. But we haven't cracked it yet, even though progress is beginning to pick up, and some big countries, including China, have eliminated malaria just in the last year or two. So unfinished business, but it's one where I think we need better vaccines, even better vaccines, more tools like drugs that last for months, not for days. And, in our lifetime, it should be possible to eliminate malaria and say goodbye to the last parasite. And that would be a huge public health benefit for huge numbers of people in mainly the poorest countries in the world. And that's still a mission.
And was there something that you saw or happened or a moment when you were on your travels that made you think infectious diseases, malaria, other diseases, this is the thing that I want to change in the world?
To an extent, yeah. So I told you that even when I was a teenager, I wanted to travel. Maybe that was a result of coming from a small island and realizing it was a big world. But I did have an uncle who had been a missionary in what was then Zimbabwe, Rhodesia, changing from Rhodesia to Zimbabwe. And he'd been there for decades. And he knew I had a long summer holiday. And he said, why don't you come out and see some of the real world in Africa? And it took me about 1 microsecond to say, yeah, fantastic. But when I got there, I was in a major teaching hospital, as was in the country, and it was horrendous. I mean, the death rate, it wasn't just that people were dying of tropical infectious diseases. There was a civil war on between the relevant parties in the country, and people coming in with x-rays that experienced physicians could identify the weapon that had caused the bone fragmentation. It was that bad at the time. So here you had not just some of the worst diseases like malaria in the world, killing large proportions of people. HIV was already a known problem, but you had a civil war going on as well. So, plenty to do was the lesson from that visit to Southern Africa.
And that made you think that there's a mission for me here. There's a purpose. There's something that I can do to make a difference.
What I do remember thinking is coming back to do some clinical medicine as a student, really for the first time in Oxford, was what the heck are the diseases people have in Oxford? They don't have any of these tropical diseases that were killing people left, right, and center. What were the chronic diseases that I was going to see? And of course, I found out fairly quickly, but very different between Africa and Northern Europe.
And in 2005, you set up the Jenner Institute. Would you like to talk to us about how that came about, your thinking, the funding, and then what you do, the focus that you have?
Yeah, I guess it came from realizing that in nearly all universities in Europe, North America, elsewhere, vaccine science wasn't really a subject that you did. Or, if somebody asked you in a pub what you do, nobody would say they're a vaccinologist. There were hardly any of us interested in vaccines. And the difficult thing, as well as the great thing about vaccines, is it covers so many specialties. You could be a molecular biologist designing vaccines. You could be an animal research scientist looking at animal models of, protecting against HIV or whatever. You could be an immunologist for your career, working out what immune response you needed the vaccine to generate to protect people or even animals against the disease. You could be a clinical trialist, finally taking the vaccine into people. You could be an epidemiologist looking at the impact of. There are all these specialties that you needed to make a vaccine. And they weren't all in the same place, those people. So we looked around and realized that, vaccines weren't often even in universities, because in the old days, the way you made a vaccine was taking a virus that was killing people, killing the virus, and injecting it into other people to try and give an immune response that would protect them. So, of course, they put the manufacturing facilities out in the countryside with big walls around them so that they wouldn't infect healthy people. Science had moved on. We had molecular biology. We were able to make subunit vaccines, as they're called, which is what we have nowadays. And there was no good reason not to have a vaccine institute in a major university. And Oxford is one of the major research universities in science on any metric. And it seemed a shame that we didn't have one. So really, luckily, there was an old institute called after Edward Jenner, about 30 miles away. And that was closing down. It was running out of money. And we kind of liked the name because Edward Jenner, of course, invented vaccines, one of the great British contributions to biomedical sciences, admittedly in 1796. But vaccines have gone from strength to strength from there. They were still pretty effective in the late 18th century. Even Napoleon and the British Army agreed to a truce when Jenner's vaccine could be distributed to both sides. And that worked fairly well. But modern vaccinology is a very different multidisciplinary area with experts from many branches of science, and bringing them together in one place in Oxford seemed a very sensible thing to do. That was about 20 years ago this month in 2005, and things have gone from strength to strength. And there are now vaccine institutes, not just in richer countries, but in every continent. So this is now a heavily funded area, one that has had some real successes. And about COVID vaccines appearing in a year when nobody knew how quickly we could even make a vaccine because we didn't make them fast enough. In my view, the whole process was too slow. And even malaria vaccines, which have been in development for over 100 years, came to the fore last year. So a lot has happened.
And before we talk about your work on COVID, just setting up the institute, was that hard work? We talked about the founding, we talked about the fact there was another institute moved in, but setting it up physically, finding the people, the infrastructure, how was that, Adrian?
Easier than you might expect. What I mean is that all the specialties that you need for a vaccine institute, whether it's sequencing DNA, molecular biology, growing microbes, measuring immune responses, doing clinical trials, we're all here on this campus, the Old Road campus in Oxford. What we hadn't done was brought experts together to focus primarily on making new and better vaccines with the benefit of all those tools. And we've had amazing people come, not just from the UK and Europe, but from all over the world. It's a very international setting here. And of course, vaccines are greatly in demand everywhere, not just post-COVID, but have been for decades.
And we talked about malaria and you leading the way in terms of that research. COVID will come on to, but you obviously do lots of work on other vaccines for infectious diseases. So do you just want to say a little about the other things that you've done in terms of developing vaccines for infectious diseases?
Yeah, the first thing to say is we're a university institute, and you might ask, why don't you leave that to companies? And that's what we did for decades. And we ended up with 4 or 5 huge companies around the world, whether it's GSK or Pfizer or Sanofi and so on, who made most of the vaccines that most of us will have had, which is fine and great and must continue. But there's some problems there. One that scares the students is when I mentioned that when the next pandemic comes along, and one will, there's no obligation at all on any of those companies to make a vaccine for the new outbreak pathogen. And of course, with COVID, GSK and Sanofi, the 2 huge European vaccine manufacturers, got together to make a vaccine and didn't in the end. It's not a requirement. There's no deal between governments and most companies that they will come to the party if they're needed. And what seemed obvious to us was that you needed a university-based research institute alternative with people who could make vaccines with the very latest technologies, because academia likes having new technology in-house, and see how that went. And of course, what happened in reality is, yes, Pfizer made a vaccine, a huge American company, but actually the vaccine was made by a tiny biotech in Mainz, in Germany, who they sort of partly bought out at the time. The Jenner Institute made a vaccine that saved huge numbers of lives, billions, in the first year alone, 2021. And that had a huge impact. But what was really different about the vaccine we made and several other vaccines is that we prioritized global health need. In other words, Africa mainly used our vaccine because we were selling it at single figure dollar prices rather, a few dollars a dose. And that meant that you could supply Africa at a sensible price, whereas other companies were selling vaccines at $200 a dose. That means 100 times less people can get the vaccine for the same amount of money. So, I'm not saying one is good or one is bad. I'm saying you need both. And there's definitely an opportunity for expanding the academic sector, and that is growing after what's been seen happening in 2020. And the other thing that people woke up to is that most vaccines are not made in America or in Europe. They're not made in Russia. They're made in East Asia and South Asia, particularly in India and China and Korea. And today, that's still the requirement, because that's where most vaccines are still made if we have a big pandemic tomorrow. And as Bill Gates himself discovered in sometime in the middle of 2020, he planned to build 8 manufacturing facilities. They take 3 years to build and approve. So if you've got a pandemic this year, it's no good for next year, the following year, maybe the third year to get something new built. You have to go with what you have. So there still is a concern that we're at risk. We've had the experience of one quite extraordinary pandemic and responded reasonably well. But we could do better next time, and I hope we will. But this is a complex topic. There are whole organizations created since 2020 dedicated to solving the problem of what we do with the next pandemic, whether it's vaccines or drugs or whatever. So yes, we are better prepared, but there's still more work to do.
And talk us through how you, the Institute, became involved in COVID. I mean, were you having cornflakes one morning and somebody said there's a case in China and you thought we better go and look at this? Or did you get a call from a government saying we're worried this is going to happen? Or how did it come about that you started your work to develop your vaccine?
Great question. What actually happened was back in 2014, you may remember there was an outbreak of Ebola in 3 West African countries. And Ebola kills a far higher percentage of people than COVID does. So it was very scary. Even nurses coming from Scotland came back to Scotland and brought the virus with them, obviously in intensive care and so on. So that was a learning experience for us. It seemed likely that something else would happen in the next 10 years, and it did. And that was COVID. We didn't think it was going to be the enormous scale that it turned out to be. That was a bit unlucky, I think. But the consequence was we set up a unit, and Sarah Gilbert was very involved in that, focused on making vaccines against outbreak pathogens, as they're often called, whether it's Ebola or COVID or Zika or whatever. The formula we had really was to take the key gene from the microbe and put it into a viral vector, as we call it, which is a killed virus or a non-replicating virus that can generate a strong immune response. So we had a technology ready to go. So in the early weeks of January 2020, the Jenner Institute was already working on designing a COVID vaccine. But, making a vaccine that you can put into a mouse, say, and test is only a tiny part of the solution. We had that technology. We had a core facility to make it. We were prepared. What we weren't prepared for was the extraordinary public interest and press interest in exactly what we were doing, both positive and negative. We had anti-vaxxers on the roof of the building behind me. We also hadn't really got a manufacturer available who could do a global supply rescue mission. So we went phoning around our friends, and very luckily the malaria program was using a manufacturer in India, which happens to be the largest in the world. It's called the Serum Institute of India. And they said, absolutely, tell us what you're doing. What's this adenoviral vector you're using? How do you manufacture it? And within days, they said, yeah, we think we could manufacture that. And boy, did they. They made billions of doses at a very low price, supplied India, supplied a lot of Asia, supplied most of Africa, and probably saved more lives than any other vaccine. It was close with the Pfizer vaccine, but both did really well. So yes, we were somewhat prepared, but we didn't really think it was likely that the scale of the problem would be what it turned out to be, where not only did you need a dose for everybody on Earth, 8 billion doses, but you needed a booster shot as well. So we're in a better place today, but we could still be better prepared.
So two questions spring to mind from what you said. One is about the speed at which you were able to develop this. Did that surprise you? And then,
I'll give you the honest answer. I think it has surprised everybody. So probably the most experienced guy in the field, certainly in North America, is somebody called Tony Fauci, who was in charge of the American COVID response. And in about March of 2020, he said, look, let's be realistic here. If we get a vaccine by the end of next year, the end of 2021, that'll be fantastic. I think we might be able to do that. And one of his colleagues went public and said, when Tony said that, I don't think he believed it, and I don't believe it either. So the short answer is nobody knew how long it would take you to make a vaccine if you really went for it with kind of unlimited funding from governments, and many of us were lucky to have quite a lot of funding available. Would it be a month? Would it be 6 months? Would it be 12? Would it be 24? As Tony Fauci said, the answer was 12. And in fact, we had the result in probably about 9 months from starting vaccinating people. So it was better than we expected. And I don't think we were lucky. I think a lot of resources were dedicated to one problem in the world, and you can really move doing that. So I think next time we can do even faster if we have seed stocks prepared, if we have manufacturing facilities humming, ready to go and not having to be built. And we know that the big manufacturing places in the world will down tools on whatever they're doing and do whatever the outbreak pathogen is. There are a lot of ifs in there, and there are agencies working to make sure that happens, but it's not certain yet. And remember, one of the largest continents in the world, the second largest, Africa, has hardly any large manufacturing facilities and the fastest growing population in the world. So I do worry about the same happening in Africa again, that they're left at the back of the queue and the rich countries rush in and buy as much vaccine as they can yet again.
And the other thing you said was that we were unlucky with the scale of what happened.
Yeah.
What do you mean by that?
I meant that if you do a very simple look back over the last 100 years and ask how many really global outbreaks you've had, yes, you've had the bird flu and the swine flu that didn't really cause massive problems. The last enormous one was 1917, 1918. And we were sitting there in 2015 thinking, when will the next one be? So I didn't think that we'd have a really big pandemic that was likely in the next 10 years, likely in the next 50 years, yeah. And I think the numbers are still the same. If you ask me when the next pandemic will be, probably in the next 50 years, but hopefully not in the next 10. And it's all to do with ecology and the mixing of humans and animals and what viruses spread. These viruses come from animals. And of course, it was the Chinese wet market that started this all off. So yeah, we were wrong. It came sooner than we expected. But it's not definite there'll be another one in the next 5 or 10 years at all. I think it'll be several decades, but we still need to be prepared.
And my last question is really about the future. I mean, what you've established at the Jenner Institute is marvelous. 20 years old now. What's next? Where do you see your work going in the future?
That's quite easy. I can look behind me and see what people are doing and predict the future. One of the big things, and I don't know how feasible it is, I don't think anybody does, is vaccines against cancer, which would increase average lifespan significantly. And huge amounts of money from big companies, from foundations are going in to try to make cancer vaccines. It's not easy. The problem is obvious. You're vaccinating against a bit of yourself. and we tend not to make immune responses against ourselves. Otherwise, we'd have horrible autoimmunity. But there are mutations there that you can detect. People are working very hard to find out if a string of beads type of vaccine with those mutations in it, given the right delivery technology, would that give you lots of immunity to cancer? The other problem is it's not antibody immunity that worked for COVID. It's the other type of immunity. It's cellular T cells you need. And they're harder to induce by vaccines. We're just less good at inducing very potent T cell responses than antibody responses. If we can crack that, I think cancer vaccines have a good chance of becoming widely used. We're not quite there yet, but new technologies appear all the time. RNA appeared just in time for the COVID outbreak and made a really useful contribution. Are there newer technologies still to come that might be more powerful? I'd like to think so. And of course, huge numbers of people are working on that to see if it's possible. So cancer vaccines, treatments for autoimmunity, inflammatory diseases, again, much more on the cellular side of immunology. But I'd be very surprised if they never came along. The difficulty is predicting it, as Tony Fauci found out. Is it going to be 2 years? Is it going to be 5 years, 10 years, 20 years? I don't think it's going to be 100. But, don't see your doctor next week.
And in the New Year's honours list, you rightly recognised publicly for the amazing work that you've done, and you were given a knighthood. But when you look back over your career and all you've achieved, what for you are the highlights? What do you take greatest pride and satisfaction from?
The malaria work, which I've spent, decades working on. And, I've been quoted as saying I was first determined to do something for malaria by working in a hospital in the Gambia, in Banjul, where the death rates were just horrendous. And the dream, and I don't think it's impossible, is that in the next 10 or 20 years, I could go back to that hospital, call in and see the resident superintendent or medic or whoever and say, where's the malaria ward now? And the answer would be, sir, we don't have malaria here anymore. Yeah. That would be the dream and the goal. And I think it's just about doable.
Well, what a wonderful contribution, Adrian, that you've made not only in the UK in COVID, but through malaria. So I'm sure on behalf of all of the listeners to this podcast, thank you for all you've done. And we wish you every success going forward in continuing to create new vaccines to continue to make the world a better and safer place. Thank you.